Hello, welcome to the video notes for lesson 10-5. This begins on page 25 of your notes packet. And this lesson is all about problem solving, which I absolutely love because that is everything that we are doing in math this year, is learning about being problem solvers. Okay, so the learning target for this lesson, I can use similar figures to solve problems. And we have a word problem here as our first example. So let me scroll down so we can see the whole problem and have some workspace. Alright, Daphne loves photography. One day she noticed a woman who looks a great deal like Miss Kula, her math teacher. The woman is too far away to be sure, so Daphne takes a photo of the woman. In a split second, the woman is gone. Daphne has a copy of the PI monthly magazine shown in the picture. So this magazine inside the magazine rack. The PI monthly magazine is 10 inches high. She thinks she can use the magazine and the picture to estimate the woman's height. So she has the actual height of the magazine, it's 10 inches, but she has a picture of it as well. She knows Miss Kula is about 5 foot 3 inches tall. Well, that's pretty short. Could the woman be Miss Kula? Okay, so here's what we're going to do. This is a word problem, so we need to use everybody's favorite, bucks. So everybody write down bucks. When I walk around the room and check your homework, I'll be looking for bucks. And first, put a box around the question. Could the woman be Miss Kula? Second, underline and circle any important information. So one thing that's important is the 10 inches high. The other thing that's important is the 5 foot 3 inches tall. Knock out any unimportant information or any numbers that don't make sense or you don't need, and I don't see any here, so we don't need the K. So last thing, solve with a smile. Okay, so here's what we're going to do. Let me move this down so we've got some room to work with. We are going to set up a proportion. First thing I need is a key. And the key that I am going to use for this problem, and you can make up, a lot of times you have control over what you do for the key, but I'm going to use the actual distance or height over the image. Remember, everything we've been doing, let me make that a capital I, over the image. Everything we've been doing in this topic has dealt with images. Alright, so we know the actual height of the magazine, so I'll start with the magazine first, is 10 inches. If I measured this image, the PI magazine is a half an inch. So I'm going to convert that to a decimal and put 0.5. Now we have the person or the woman. Oops. We don't know the actual. That's what we need to find out so we can see that if this person is Miss Kula. Remember, Miss Kula is 5 foot 3. But we do have this image, and if we were to measure it, it's not actually this, but we're going to use 3.5 or 3.5 inches. So everything we're doing is in inches. So keep that in mind because remember, Miss Kula is 5 foot 3. So when we're done, we'll need to convert it to feet. Okay, so a strategy for solving proportions is known as cross multiplication. Be careful because some students use this strategy for problems that it's not acceptable, but it is for this. Alright, so when you cross multiply, 0.5 times x is 0.5x. 10 times 3.5 is 35. So I have an equation. So to solve it, I divide both sides by 0.5, and you end up with x equals 70. Now, remember, this is inches. We need to find out how tall this person is in feet. So if you divide 70 by 12, you get 5 with a remainder of 10. So what that means is 5 feet 10 inches. Well, Miss Kula is 5 feet 3 inches. There's a big difference between 5'10" and 5'3". So the question is, could this woman be Miss Kula? The answer is no. This person is not Miss Kula. Is not Miss Kula. Because she is too tall. Alright, that's it. So, pretty simple stuff. Over on the next page, page 26, we are going to talk about something very important. So one way you can use the fact that corresponding sides, okay, that's a pretty big piece here, of similar triangles are proportional, is to help you find lengths that you cannot measure easily using a ruler or other measuring device. This is called indirect measurements. Indirect measurement. In other words, if you wanted to find out how tall a tree is using a ruler or even a tape measure, would be very difficult to actually do. In some cases, maybe even impossible. So how are you going to find out? Well, you can use this indirect measurement to find out how tall something is. And we'll see an example, a very good real-world example, like how tall a building is or a house. Okay, your friend wants to find the height of a building. The building casts a shadow of 15 feet long. Your friend casts a shadow of 3 feet long. If your friend is 5 feet tall, what is the height of the building? Okay, so let's go ahead and write down bucks. It's a word problem. Organize all the information. So, box the question, what is the height of the building? That's what we're trying to answer. You underline, so your friend casts a shadow of 3 feet long, your friend is 5 feet tall. Circle, 15 feet long, that's the building. So there isn't any unimportant stuff, so now solve with a smile. Okay, so here's the building. The sun must be up here. Go ahead and draw yourself a happy sun. And it's shining over here, so the building casts a shadow this way. The shadow is not this diagonal line. It's actually the line on the bottom, and you'll see building casts a shadow, and it's pointing to this. The friend casts a shadow, and it's pointing to this. Now your friend is 5 feet tall, the shadow is 3 feet. So your friend is taller than the shadow. So one thing we know, when we're done, our answer, the height of the building, x here, needs to be bigger than 15 feet because it's got to be bigger than the shadow based on what your friend is. So this diagram here kind of shows what we have up here is your friend, the building are right here, so this is x, this is 5. Then we have the two shadows overlapping on the bottom. Here we have the two triangles that are pulled apart. So this will be the triangle that represents your friend. So the shadow is 3, your friend is 5. The building is here. The shadow is 15, but the height we don't know. We've got to figure that out. So here is a key that we could use. Now notice I say we could. There are many ways to set up a key, and a lot of times you can do whatever you prefer. I am going to use the shadow height and put that over the actual height. So what does that look like? All right, first I'm going to take your friend, and the shadow height is 3 feet, and the friend's height is 5 feet. That equals, okay, now I have the building, and the shadow height is 15, and the building height we don't know. Now we set up a proportion. Remember, so one thing you can do is do scale factor method. What am I multiplying the top and the bottom by? Actually, that's an easy one. Let's do that. 3 times what is 15? Now, if it wasn't easy to do this, we could always do the cross multiplying, but since it is, let's use it. So whatever you do to the top, you do to the bottom. So I multiply 3 by 5 to get 15. So what's 5 times 5? 25. So x equals 25. What does that mean? That means the height of the building is 25 feet. Dun, dun, dun. Now, just another example for you. If you didn't want to do yours this way, let's say you set up your key and you did shadow over shadow equals height over height. You could do, so the shadow of the friend is 3 feet, the shadow of the building is 15, equals the height of the friend is 5, and then the height of the building is x. Now with this, you wouldn't be able to do 3 times what number gives you 5. I mean, there is a number that would work, but it's a little harder to see. So you might do cross multiplying. But this proportion will give you the same answer as what you have up above. You do 3 times x is 3x, 15 times 5 is 75, 3x equals 75, x equals 25. So it would still work. Okay, next page, page 27. I know the video is getting a little long, so we're going to move this along here. A scale drawing. We're going to talk about this a little bit in math, probably before and after you do this lesson. A scale drawing is an enlarged or reduced, so that's what we do with dilations, drawing that is similar to an actual object or place. Floor plans, blueprints, or maps are examples of scale drawings. The ratio of a distance in the drawing corresponding to the corresponding actual distance is the blank of the drawing. I think scale is supposed to be here. So before any of you go, oh, I found a mistake, I found it too. Alright, so I've already gone ahead and measured this picture. Let me, I'm going to clear the screen and move this up. So I measured the living room, and for this distance here, I got 2 3/4 of an inch. And this distance here is 1.5 for the living room. That's going to be the first problem. The second problem is the bathroom. This is 3/4, and this is 7/8. Alright, so we're going to do the living room problem. That's the first one here together. The second one is the bathroom problem. I'm going to let you try that on your own. Okay, based on the blueprint, what are the dimensions of the living room in feet? So we have the inches, we have the scale, 1.5 inches equals 10 feet. Now we need to find out what this would be in feet. We're going to use the key of drawing, so the drawing measurements over the actual. Alright, now, I only need to do this for the one dimension because this right here, if it's 1.5 inches, I already know based on the scale, it's 10 feet. So I have to figure out what this is. So I know that the scale is 1.5 inches gives me 10 feet. Well, I have 2 3/4, so I'm going to convert that to a decimal. You could leave it as a mixed number if you want. It's not a bad decimal, so I'm going to convert it over x. Now, 1.5 times what gives me 2.75? I can't really tell what that is, so I'm going to go ahead and use my cross multiplication strategy. And when I do, I get 1.5x equals 27.5. So I divide both sides by 1.5, and at first it looks like an ugly number. X equals, and it's 18.3 repeating. Now, 18.3 repeating is really 18 1/3. 1/3 of a foot is actually a nice number. If you divide 12 by 3, you get 4. So, because there's 12 inches in a foot. So the distance here is 18 feet 4 inches. And that's actually a fairly standard length, about 18 feet. So, what are the dimensions of the living room in feet? The dimensions of the living room are, or is, I should say is 10 feet by 18 1/3 feet. I'll leave it as that. Period. Alright, so now you're going to do the same thing for the bathroom. Now, I'm actually going to help you out with one part of this, and then I'll stop the video. This 3/4 is actually half of 1.5. So what does that mean? This is 5 feet. So all you have to do is try to figure out the 7/8, and you will be done. Alright, that's it for this video. If you were confused, go back and rewatch it, or come and see me for help. Good luck, and we will see you in math.